Good morning, class. This is Mr. Reynolds. We want to continue from yesterday when we were looking at the outer structures of the ear. So we want to do a quick review with that, and then we'll get into the sensory organs of the ear, where it senses hearing and balance. Okay. So the structures from yesterday, well, we saw the auricle, which is the outer part of the ear, and it acts as a funnel to conduct sound waves into the auditory canal made from the external auditory meatus, the opening in the bone that goes through. Then the sound waves hit the eardrum, known as the tympanic membrane. Okay, it vibrates a little bit, and it makes the malleus or the hammer vibrate. It makes and that taps onto the anvil or the incus, and that taps onto the smallest bone in the body, the stirrup or the stapes. Okay, that lightly taps on the oval window, which is the connection between the stapes and the and basically the vestibule of the cochlea. Okay, structure. The snail-shaped structure is the cochlea, and that's going to be the organ for hearing that we'll look at today. These three half canals or semicircular canals up here are for dynamic equilibrium, and the chamber in between, we'll see this today also, the chamber between the snail-shaped structure and the semicircular canals, between the cochlea and the semicircular canals, is the vestibule. Okay, and we'll see nerves that vestibular nerve. You can see the branch of that leads into the vestibule and the semicircular canals, and you can see the branch of the cochlear nerve leading into the cochlea. Okay, of course, like we said with the throat down here, the eustachian tube leads down to the throat, and we said yesterday a lot of times people with throat infection, you know what, a week later they might end up with an inner ear infection also. Okay, so that's reviewing from yesterday. And as we move on, we mainly want to look at the ear sensory organs today, and that's the organ of Corti, which is in the cochlea. That's for hearing. Okay, the macula is in the it's in the vestibule. Okay, and we'll see two different parts of that, the utricle and the saccula, when we see that. And then the crista ampullaris is in the ampulla. I'm sorry, let's try that again. It's in the ampulla of the semicircular canals. And this is going to be for dynamic equilibrium, and we will show all this again in later slides. Okay, here's a simple look at the basically the middle and some of the inner ear, where we have the semicircular canals. We're going to see this area for dynamic equilibrium. Static equilibrium is this section right in here. Like I said, this chamber between the snail-shaped structure, the cochlea, which is for hearing, okay, and the semicircular canals. The chamber between is called the vestibule. And it's composed of, basically there's two parts, two different chambers. They both have the same type of sensory organ in them called a macula. But the chambers are called the utricle and the saccule. Saccule. Okay. All right, next slide. That's a simple at it. A little more complicated look. Again, we see the cochlea is the snail-shaped structure over here. We'll see the branch of the nerve coming to it is cochlear nerve, the cochlear branch. The branch of the nerve going to the vestibule is vestibular nerve. Okay, and remember these nerves end up tracking together in the auditory or acoustic nerve, or you can call it the vestibulocochlear nerve, and it goes up to the brain. And yesterday in the slides we saw it was cranial nerve, actually it's 12 of these, cranial nerve number 8. And I meant that there's 12 different cranial nerves. This is the one for that senses hearing and balance. Okay. Semicircular canals, 1, 2, 3 for the 3 different positions of it. And in here, in the ampulla, we'll see each one of these bulb-shaped ends of it is an ampulla. There's going to be an organ called the crista ampullaris in there. Okay. In the vestibule, the area between the semicircular canals and the cochlea, the vestibule in here is going to be composed of these 2 chambers, the utricle and the saccule. Okay, the sensory organ here in the green is going to be the macula. All right, and yes, there is fluid in these. The purple fluid is endolymph. Okay, and it's contained inside some membranes. All right. Outside of all this is some bone. Okay, as you can see out here where I'm coloring black right, this is all bone around it, all bone, 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 bones. These canals are in bone. Okay, so actually the name of this this tan stuff, since it's still bony labyrinth. Okay, labyrinth means chambers in there. Okay, so chambers through the bone filled with some fluid. Okay, fluid in here, fluid in the bony chambers is called perilymph. Okay, fluid in the purple part, like I said, the purple fluid is the endolymph. All right. Okay, moving on. Here's just I thought was a cool looking slide of this cochlea laying on its side, and it's all wound up, but it's all pretty much one thing. And the next one, and where the light pinkish purple is almost this is the section that we want to be at. This is where we're going to see the organ of Corti, the organ for hearing, and this is endolymph in here. Okay, and we'll show the flow of fluid in the ear in just a moment. Okay, but that's a sideways look at it as it's all coiled up. If we uncoil it, it's going to look like this. Okay, so reviewing tympanic air. Vibrations hit the tympanic membrane, taps on the malleus, taps on the incus, taps on the stapes, taps on the oval window, okay, which sets up vibration in the fluid, okay. It's going to have it vibrating around here, around, and it's going to make its way back to a thin membrane called the round window that you've seen labeled, and it vibrates back and forth just a little bit, and then the vibration in the fluid is done. Okay, now meanwhile, back after the stapes is tapping onto the oval window and it's setting up fluid vibration, it's not just going around, it's also hitting this inner membrane, the inner chamber of it. Okay, and this is a part that we want to focus on, and let's look at the next slide as we're doing that. We're getting to the organs for hearing here, and that's what it's going to. This is if we look at that cross section of it, we'll see an outer, this was some perilymph out here. Okay, and it's going to be pushing down on, it's going to bump into this chamber in that contains endolymph. Okay, and this is really what we want to look at right here. Okay, the endolymph, and this is an enlargement down here. As this fluid on the outside pushes on this inner chamber, it sets up a little, there's some fluid that moves in here also. And the fluid, I'm going to enlarge this now. This blue membrane, it's now down here. It's now this one, okay? So the endolymph is now pushing down on this tectorial membrane in waves, okay? Pushing down in waves on this thing. And the whole membrane comes down and pushes on these sensory hair fibers that are growing out of this cell. Each one is a single cell. You can see its nucleus right here, okay? And it's got some sensory, and they call them sensory hairs. We should be calling them sensory cilia. as they're sticking up from here, okay? And the shelf is pushing down on. When it pushes down on and it touches these cilia, it sets up an impulse that sends a stimulus electrically through the nerve, through this branch of the cochlear nerve, off to the brain, okay? And you see the nerves coming out of the branches of nerves coming off of each one of these sensory cells, okay? Now I'm going to sketch one over here because I think we need an even larger view. So here's a view of the cell. Here's a view of the cell. Here's its nucleus. And the sensory cilia coming out of it. The sensory cilia coming out of it. And we see nerve endings coming out the back. Okay. Pretty much one nerve for each cell. It's very sensitive. Okay, so another cell with its nucleus, cilia coming out of it. Okay, when this shelf shoves down on it, okay, when the shelf is shoving down on this, it could actually, if it shoves down real hard, like listening to loud music, and you have something to read on decibels, okay, that's erasing the whole line. Let's go back and change that a little bit, okay. I'm going to make these cilia a little smaller now, because once you damage the cilia, that's it. These parts, they don't really regrow. As far as we know, they don't, okay. And like I mentioned yesterday, I had a roommate that I'd walk into the living room and it almost hurt my ears when he had the TV up so loud just so he could hear it. Okay, but he had damaged his cilia before, so he had to have the really loud vibrations pushing this tympanic membrane down into the cilia. Okay, just so it would actually stimulate those because he had those damaged. A normal person, if the hearing is not damaged, they're going to have typically longer cilia. All right. So once the tectorial membrane hits the sensory cilia, okay, it sets up an impulse, and that is conducted out of this branch of the cochlear nerve, and all of them start traveling together on their way up to the brain. Okay. Next. Okay, here's something that you'll read later on decibels. Oh, wow, we're seeing this one again. Okay, we are now going to take a look at the sensation of dynamic equilibrium. Dynamic equilibrium, so that's movement, okay, and this is going to be with the semicircular canals. Next. And we'll see each one of these in the ampulla. This is where the crista ampullaris is going to be as we take a look at that. And as it gets stimulated, again, you're going to see some sensory hairs, and they're going to send an impulse through this vestibular nerve. Okay. Here is the crista ampullaris. You can see it's a gelatinous mass. The whole structure is crista ampullaris. Here's some sensory cells with the cilia or hairs coming out. Oh, and they say these light tan ones are supporting cells. You see those all throughout. You can barely make out the nucleus on each one of these, okay? But the blue ones and the tan ones in between, the tan ones supporting cell, supporting cell, supporting cell. Here's a sensory, all the blue ones are sensory cells. You can see the nucleus pretty much near the bottom of it, okay? Out of each one of these sensory cells, you see a nerve ending coming out, okay? Nerve endings coming out of these, that when they get stimulated, it's going to send the stimulus up the branch of the vestibular nerve, joining with the cochlear nerve up to the brain, okay? In the ampulla, this half circle, this semicircular canal, this is where we find the ampulla, okay? And with fluid in here, as fluid, if you turn your head this way or move this way, or you're running, you're moving, up and down movements, and there's 3 semicircular canals set up for the three different positions: forward movement, sideways movement, if you're leaning too much, trying to get any little change in movement. And this, like I said, these sensations are sent up to the brain, and they help to control really your sense of balance. So as the fluid moves against these, it's going to push this cupula, that's the top cap of this, that's gelatinous mass. Picture Jello in here, okay? And as this whole thing shifts over a little bit, these sensory cells are tugged on a little bit. It sets up a stimulation that goes into the sensory cell, out the neuron, up to the brain. Okay. Next slide. So in movement, if someone is moving their head really fast, rotating it, like you see in this diagram, the fluid gets going around. And if they turn their head in this bottom diagram here, if they turn their head to in the really opposite direction of this is going, the fluid goes in the other direction. Okay, kind of and it pushes it that way, and that tugs on these fibers. As it's being pushed in this direction, the fibers get tugged on. They send up an impulse. Okay. Next one, and this slide that you'll read later also applies to some motion sickness, and that's going to be that fluid going round and round and round in the semicircular canals. Okay, my younger brother, when we were young, he could ride some crazy rides at the fairs, just to have him turning all over the place, and I'd be one who would get sick on bumper cars, but it really didn't mess up his semicircular canals that much, the fluid going through there, but some people can't handle motion sickness at all. Okay, and this last one, here's a familiar slide again. So we're looking at the third. We already looked at sense of hearing. We looked at sense of dynamic equilibrium. And now in the vestibule, we want to look at static equilibrium. Okay, that's basically, it's going to basically associate a lot with the position of our head. As I said, these two chambers, here's the utricle, here's the saccule, and the structure that we'll see in there is called the macula. All right, and that's labeled on this next more detailed slide. The macula is going to be the sensory organ inside the saccule, and there's one inside the utricle also. These are two distinct chambers of what's called the vestibule. Okay. The area, the bony area, the chamber between the semicircular canals and the cochlea. Okay. So in looking at it, and by the way, this is the last slide also. Now what's cool about this macula, it's basically gelatinous mass again. It's sensory cells with sensory cilia or hair fibers sticking out. You see the nucleus from each one. You see the branch of the nerve, and this again, this is going through the vestibular nerve. They will all track together. If someone's head, if their head is in the normal position like we see here, well then we also see this would be the shape of the macula at that point. Oh, and this is cool. These are called otoliths. They're little stones in the top of it. It's just going to make, and it's inside the gelatinous mass. Okay, it's not sitting on top of it. It's basically inside this gelatinous mass. What is sitting on top of a thicker portion a little bit? So if there's any movement at all, it's going to help force with that. If there's any change in gravitational position, these will change also, and that will be much quicker at setting up an impulse through the sensory cilia. Okay, if someone has their head tilted, then it's like this top structure here. Many of these otoliths are going to be coming this direction. You can see how the sensory cilia are being tugged down this way now. Okay, that's going to set up impulse. It's going to carry impulse to the brain, not the vestibular nerve, vestibular branch to the brain, and letting the brain know that, the head is not in the upright position now. Okay. So those are pretty much the three structures of it. As I said, the macula, helps with static equilibrium. The crista ampullaris helps with the dynamic equilibrium, and the organ of Corti in the cochlea helps with hearing. Thank you very much.